Well, today I thought we might start a new little segment, and I think rather than call it mailbox, I'm just going to call it something like this and that. If you see this and that, that's what it's going to be about. It's going to be any little thing that I just want to spout on about or just want to spend 10 minutes playing with. Well, as you can probably see in today's episode of This and That, we've got quite a few things here to look at, so I think we'll just kind of start at the top and we'll unbox this one first. Or unbag, it's not in the box, is it? We will unbag it. I think unbagging, debagging means something completely different, isn't it? So maybe we shouldn't say we're debagging. Right, okay, so plastic box. And some metal boxes. And some carbon composite resistors. Bet you didn't know you could still buy them. They're old-fashioned looking, aren't they? But they're actually brand new from RS. And while we're talking about unnecessary packaging, let's see that they sent me a separate envelope with another pack of resistors in. Why they couldn't go in the other package, I don't know. Now, I've got no idea why RS couldn't actually send these packs of resistors in the same envelope, but I don't know, do you think they might fight or something? These resistors are going to go with these boxes. I think you know that I plan on making a video at some point. I will get around to it eventually on FM quietening. That's basically, it's an old-fashioned test that used to be done back in the day before people had all these fancy cyanide meters. And it allows you to get an idea of how sensitive a receiver is without any fancy test gear. Oh, you do need an RF signal generator, but you only need an AC voltmeter and to do the test, plus the radio receiver that you're testing, of course, and maybe an attenuator box. Actually, you need quite a lot. Shall I start that again? So I've got here some nice die-cast aluminium boxes. In fact, let's just open one so I can lose all the screws and then curse about it later. Well, the reason I got metal boxes is because I wanted something with RF shielding, which, you know, a metal box is shielded. Let's just make sure they fit that. So there we go, nice little aluminium die-cast box. So the other thing I've got that goes with these boxes, I've got some packs of resistors, and that looks a little bit like the type of resistor you might have found in an old valve radio 50 years ago. And just so for comparison, here's a little modern, I think that's probably something like a metal film resistor, something like that, I'm not exactly sure, probably metal film. But this one here is a carbon composite. So these resistors are carbon composite, and the reason that I chose these carbon composite resistors is because I'm going to use them in an RF application. So what I'm planning to build is something called an impedance matching pad. As you know, most of my test gear that I've got here, in fact all of my test gear, works around 50 ohms. That's the impedance it's looking to see. Back in the day, a lot of old radio receivers, and in fact even some modern VHF receivers, and television stuff, it doesn't all use 50 ohms. Lots of a domestic type of equipment uses 75 ohms. Well, that does create some problems if you want to connect 50 ohm test gear to a 75 ohm impedance device. I mean, the reality is it will still work, but you can get some misleading results. Power levels and things may not absolutely match, and you know, you can get the usual things of reflections and stuff like that. So what you need to do is you need to do something to match the impedances. Now I am going to show you building this box in detail at some point, so I'm not going to do that now, but the arrangement will be something like this, where a connector at each side of the box, there'll be a resistor in the middle, and then there will be two additional resistors down to ground like that. So that's the through path, and then both these will be grounded to a lug on the side of the box. But one side of the box will be a 50 ohm input and the other side of the box will be 75 ohm inputs. It doesn't really matter which way around you put it, as long as, you know, we'll have to mark, one side will always be 75, the other side will always be 50, but in terms of input and output you can mix and match, it doesn't make any difference. And I'm going to build two of these boxes because I kind of want to test the performance of them. So what I'm going to do is we'll put two of these boxes built together. So we'll have 50 ohms coming into this side, that will be 75 ohms coming out of here. Then we'll have 75 ohms going into this side of the box and 50 ohms coming out of the other side. So what we will be able to do is we'll be able to plug two of these boxes in together, connect it up to the spectrum analyzer, which is expecting to see 50 ohms at either side, and we'll be able to use a tracking generator to do a frequency sweep and look at the RF response. Well, I don't know about you, but I'm a great one for tradition. And one thing that's certainly become a little tradition in my book is on a Sunday, I like nothing better than to tune into the Radiocrucher's channel. That's run by Graham. And he has got a live stream that he puts out on Sunday morning. And it really is very entertaining and absolutely enormous fun to go on there and just abuse him for a bit. He absolutely loves it. So if you've got nothing better to do on Sundays, which if you're watching me, let's face it, you probably haven't, go and watch some of Graham Radiocrucher's videos. Well, on this week's live stream, Graham was telling us all about his latest drug addiction. I think he got through 4 or 5 bottles of speckled hen. Not that I was counting, Graham. I think he was probably half cut at that time. He started abusing Felicity Kendall of all people. Oh, then the bouzouki music came on, and one of the things that he featured was a signal tracer, which he actually used to great effect. Now, I've heard of these signal tracers many times, and certainly they're kind of an old idea. And what it really consists of is, one part of it is an audio amplifier, which is what this board is here. And then you have a hand probe that's got a rectifying diode in it. And what you can do is you can actually use the signal tracer inside a valve radio or a transistor radio he was using, and you can inject an audio or an RF signal into something like the IF path, and then you can use the audio amplifier side here to probe around in the circuit, and you can basically just listen to signal levels or listen to the place where the signal disappears in your radio that you're trying to repair, and there's your problem. So he had a signal tracer that was quite nice that he'd built himself, but he also went on to comment that in the past he'd got one of these Velman signal tracer kits. So and he said he hadn't got round to building it yet, so there's a little bit of a race on now that I have to get this kit out. Let's see if we can open it up. I have to get this kit out, and I have to try and build it before up before Graham does. So that's what that's going to be. Ooh, all the parts have fallen everywhere. Oh yeah, okay, we've got some instructions there, so that's nice, isn't it? There's another episode, isn't there? Building one of these signal tracers and me having a go at using it because I've never used one. Well, if anybody's interested, I actually bought this from Amazon, and it was about £13 delivered, and I think that was actually cheaper than I could buy it from China from. There was a few places online in China that were selling this. For whatever reason, most of them were around £15. Well, this thing delivered was only £13, so I thought that was quite good. And to go with that, I've also bought this plastic box. I got that from RS. So in theory, the circuit board will go in this plastic box here. The pots will stick through the front of it. We've also got to put, because it's an audio amplifier, this, got to try and put a little speaker inside as well. I don't think it needs to be a particularly good speaker. And then the other thing we've got to build is this hand probe, which there's different types of signal tracing hand probes, and the design varies, whether they're designed for AF use or RF use, or some of them have a little switch on the front and you can switch between RF or AF. And I think the main difference is if it's in RF mode, it uses something like a germanium signal diode as a detector, so it rectifies the RF signal, it detects it and then amplifies it, and you can hear the incoming radio signal through the loudspeaker. So that's kind of how it works in principle. So that's another little construction project that we're going to have coming up at some point in the future. Okay, so we've got a bigger box now, so as far as I know there should be 2 things in this cardboard box, but 2 things, maybe there's more, something else in there as well. So let's open this one first. I want to be a little bit careful with my sharp knife here. It's quite well packaged up, that, isn't it? So this is another of my eBay buys, another drunken night on eBay buying stuff I don't need. So let's see what I bought today. I'm sure the wife will be pleased. She loves it when I bring all this crap and fill up the house with it. In fact, she was saying to me the other day, Chris, we definitely haven't got enough crap in our house. Please go out and buy more. So she'll be glad to know that I did. There. Right, so I've bought some more, hopefully, broken CB radios. So we've got this Midland 3001, and I actually quite like the look of this. I thought it looked like quite an interesting radio. I was going to try and power it up briefly, but just looking at it, the power connector's smashed off the back. and actually the back of the radio is a little bit stoved in as well. So yeah, that one's going to need a little bit of work, isn't it? But fingers crossed, you know, I wanted something to repair. If it works, it won't be any fun at all. So that's definitely a repair video. And this other one is described as, this one's a bit grubby actually. It's a York JCB 861, and again this has got the CB 2781 on it. So that means it's an FM radio and it's legal for the UK. Now I've got to admit, I've got a bit of a guilty secret, because I'm actually a CB racist. You know, you get some people that don't like people's skin colour. Well, I've got to admit, I don't really like CBers, which is unfair because I was a CBer myself, and CB is a great introduction into amateur radio. You know, they call CB, they call the FM band, they call it the Muppet band, and they call it the Muppet band for a reason, because it's just full of idiots. And I switched on the CB the other day, and it really doesn't seem to have changed much. It just seems to be full of people shouting and swearing, and I don't know. It didn't impress me. Now it looks as though we've had some water in here, and it looks as though the printed circuit board was actually soldered to the back case, but that's cracked off. I can also see it looks like there's maybe a power transistor living down here. I don't know if that's like the main output PA for this radio. But again, I can see that all the pads around there, they're all a bit bastardised. So it looks like certainly people have been inside this radio over the years, and certainly it's had power transistors changed. The board also looks a little bit twisted and distorted. It's definitely pushed in down here. So I don't know what's happened there. Yeah, it's definitely pushed in. Let's hope the board isn't actually cracked. So the final bit of tech porn for the day is this Micron. What do you call it? A VOM? Volt Ohms meter? I don't know, VOM, whatever. And it's a Micron. What model number it is for those playing along at home? It's, is it on the box? Does it have a model number? 22220A. Performs like a VTVM, what's that, volt tube voltmeter, because they're actually boasting here it's got a FET analog, well it's got an analog, start again, they're bragging here because it's got a FET analog input, so it's using a FET transistor, so rather than having to directly power the coil that wangs the needle across, rather than that being directly connected to the input connectors, the input connectors are actually connected to a FET. So basically what we're saying by having a FET here, the input impedances will be an awful lot higher. It's going to be much higher than something like, you know, the original AVO 8, which was it 20,000 ohms per volt or whatever it was, something like that per range. This will be much higher input impedance than that because it's got this FET analog switch, or FET analog transistor built into it. Now, I have to say I quite like the look of this Micron meter. It seems quite solid. I was going to say it seems quite well made, but yeah, that switch needs gluing back on. It's not gripping the shaft of that switch inside. But yeah, so I'll have to have a look at that. But that's a very nice, positive, clunky switch. Nice scale. It's got a mirror behind it for parallax error. Yeah, I remember Micron meters with an awful lot of fondness. Micron, of course, was the brand of, well, it was Tandy in the UK. You American people will know it as Radio Shack, of course. But back in the day, my first voltmeter, which was, it wasn't anywhere near as good as this. I probably couldn't afford this when I was growing up. My first meter was a Micron. And I think my first digital meter might have been a Micron as well, but certainly that's a long time ago. But I do remember the brand with fondness. Probably for the greater part of my life I was using an analog meter, something like this with a needle on it, a traditional meter, rather than a digital voltmeter with a digital display that everybody uses today. And you kind of forget what it's like, or certainly I've forgotten what it is to use a meter with a needle on it, because I haven't done it for many years. Now, of course, because I'm into electronics and I live in the UK, I've got several AVOs. And yeah, although in polite conversation I'll always say how much I like AVOs, because you're not allowed to say anything against AVO. It's like great British brand, but I've never been much of an AVO fan. You know, they might be good, but they're bloody heavy and they're annoying to work on. And all these meters, all these old meters, had different input impedances. So what you will see is, you will find if you measure the voltages stated in an old manual, if you measure them with a modern voltmeter, all the voltage will come out much higher than you expect, and it's because your modern voltmeter, your modern DVM with its 10,000, sorry, with your 10 megohm input impedance, it's a much higher input impedance than your 20,000 ohms per volt, whatever, that the AVO 8s had on them. So you get misleading readings. So when you're working on old valve gear, it's good to have an old meter. Now, of course, the other thing about having an old meter is when you want to do things like radio alignment, you want to see a needle going up and coming back down. You don't quite get the same thing with a digital meter. Even though some digital meters have like a horizontal bar graph, it's not as nice as having a true needle. And you can watch the needle go up, and as you start to tune things, you can watch the needle fall back. It's a much more real-time experience, much easier for setting things up. Again, when I do this FN quieting test, it just requires us to use an AC voltmeter, so I thought we could probably use this. And I think it's going to need some batteries in it. Now, I went and bought some batteries the other day. These cost me about as much as my left bollock. When do you go to the supermarket and you buy 2 small packs of batteries and it comes to £8.50? I mean, they really must have seen me coming. And C-type batteries. C-type batteries, what are C-type batteries all about? I mean, where do you even put C-type batteries? I bet I haven't seen a C-type battery in 20 years. D-cells, you know where you are with a D-cell. You can get your D-cell batteries, you can stuff them into your mag light and you can go out and club somebody to death with it. But C-cells are just pathetic, aren't they? I mean, I can understand, like, what's wrong with AA batteries? Even the typical AA. Nothing wrong with AA, you find them everywhere. I go in my wife's bedside table and she's got a drawer full of AA batteries. Got no idea what she does with them, but she certainly seems to go for a lot of AA batteries. You've got things like AAA batteries. I mean, they're like the little man of the battery world with a big chip on its shoulder, aren't they? So, yeah, but C-types, I'm going to throw this in the bin, right? This is a new battery, but let's face it, I haven't used a C-type battery in 20 years. By the time I need to replace this battery in the meter, this one will have gone flat anyway, so yeah, I'm going to just cut out the middleman. It'll save it turning to dust in a drawer somewhere, so that can go in the bin. So we will put that in there. Which way around does it go? It goes that way. And we need a 9-volt battery. See, that's the other thing about these old Micron meters, in that they actually came with a proper manual. I mean, you buy some quite advanced test gear now, and it comes from China, and you pay nothing for it, but you know, it comes with like a sheet of A3, half of it's in Chinglish and French and German. Well, they actually wrote a pretty huge manual here, and yeah, all this manual is in English. It goes into great detail how to set the meter up, how to use it with, I don't know, crocodile clips, what the red and black lead does. Well, there's a circuit diagram in there. I don't think they've given us a circuit diagram, which is a shame. It's always nice to have a circuit diagram. But it's a proper thick booklet. And if you'd have bought this meter as a kid or a young man, you could have got this and you could have studied the manual, and you know, I would have enjoyed reading this with great pleasure back in the day, and I'm sure I would have learnt something, but not today. You can probably tell I'm a bit hyper today, aren't I? It's because I had a big bottle of Tizer with my dinner, so I've been buzzing around the office all day. Oh yeah, okay, we are working, so that's ohms. I think, I'm trying to remember how you use an analogue meter now. It's back in the day. I think, don't you have to put it on the ranges and then you zero adjust, is it that one? Ah, right, okay. Yeah, a bit of a trap there. These are, because it's got FET input, these don't always behave themselves. Actually, it reminds me, AVO did also make one of these FET input voltmeters, and I used to have the AVO version, and I actually gave it away to a friend because the batteries were always going flat in it, and when it got flat batteries, it used to read high on the input. And to be honest, I just thought that was a pain in the arse, so I did give it away to one of my friends. What I did was I just turned it onto the AC range, and I was just a little bit perturbed to see that the needle had wanged over there somewhere, and it's because it has this FET input. You must have to set the bias level on the FET, so you obviously put it on the range you want to use it on, and then you use this zero adjust control, and you set it to 0. I'm not sure about the ohms range. Let's put it on ohms, 10,000 ohms. And now can I just... Maybe we got some dirty... Yeah, I think we might have some dirty switches here. Yeah, I just shorted these together and the needle kind of went over and it got almost to the end and then it kind of stopped and then had a little rest and then carried on its way. There we go. Ooh, we can do it. Yeah. So it seems as though it goes a little over a little hill around where that free is. Let's see if it... Is it just the meter? I mean, this meter hasn't been used in years. Go on, you can do it. That's really strange. I mean, I don't. Maybe I should just give it a bit of a twist because this meter's never been used. I can tell it's never been used. It hasn't got a mark on it. Go on, have another go. Take a run at it. That is bizarre, isn't it? I don't know what's going on there. It says it's got a bleep range continuity. Let's see if the bleeper works. Oh, well, that passes the Dave Jones bleep test instant. I might actually use this meter in the garage. I actually quite like to have an analogue meter when I'm working on the car and stuff like that. This might be quite a nice meter for the garage. It's also got quite a good current range on it. I think I saw that. It goes to 10 amps on the current range, so that's usable, isn't it? I'm not going to exhaustively test it today. Let's try the voltage range. My power supply is still set to 13 volts up there. So let me just trim this voltage control here, and I'm going to stick my big head in front of the camera. Actually, I got that pretty good on the parallax error, so that's looking quite good. Let's put it on the 30 volt range, and we're looking for 13 volts. Let's see if that goes up to 13 volts. We're on the scale here that goes from 0 to 3 because we're on the 30 volt range. That's a bit of a jump, isn't it? 10 to 30 volts. You'd think. Is that what they always did? That seems like quite a big jump in voltage from 10 to 30. Okay, so we're on the 30 volt range and it's indicating on here, it's easier to count back from 15 volts, so 14, just over 13 volts. I'm not going to comment on the accuracy of these things. They're probably as good as you can be bothered to read them. So okay, so we've got a nice little micron-to-meter here, haven't we? Nothing wrong with that. And we'll use this in a future video. We'll have to get this out in a future video, and I'll get the Avo out and we can have a swear at that as well. Now, I don't know if you remember earlier we were looking at these carbon composite resistors, but I don't think I told you what value I'd bought. So here's a little quiz for you. So we're on the times 10 range now, and what I'm going to do is I'm going to just measure the resistance of them, and you can tell me what the value is. No cheating. I can see some of you trying to read the colour bands. Now I'm going to move it. So what's that? What's the value of that resistor? We're on the time 10 set. We're on the time 10 range, and we're on the green scale because we're on ohms. So that's the top scale. So what's the value of that resistor? Now I can see all of you just moving your head around trying to line up the needle with the mirror, because I need exact readings. There's no point giving me in the ballpark. I want exact readings. So that's the first one. You've had long enough there. Let me find the other resistor. Okay, so here's the second resistor. If I can keep my test leads on it. Okay, let the needle settle. Are we there? So we're still on the times 10 scale, times 10. And I think that's enough. Okay, so whatever reading you think that is, leave it in the comments and I will tell you next time. So I think for today's first episode of This and That, I think that'll do. But if you want to see another episode of This and That, you thought it was interesting, leave it in the comments, give me a thumbs up. If you don't want to see another episode, you don't have to. But until next time, that'll do. As always, thanks for watching. It's great to have you at the bench with me. It's great company. Hope to see you again very soon. Bye bye for now. Bye.